Hey everyone, thank you for joining us here on our first video where we would like to showcase the new CAEN ELS graphical user interface we have available on several of our units, including the FastPS, FastPS 1K5, and NGPS series. So we're running this from a Chrome web browser tab. The web page comes straight from the supply with a built-in web server. So all that one needs to do is type in the IP address in the address bar, and that'll be the IP address of the unit connected through Ethernet, and that's all that's required. So let's get started. We did skip the login screen, which would simply ask for the password. And once you put that in, it would bring you to this page right here. So starting off on the left-hand side, we see several indicators, including the fact that we are in the remote mode. The output is currently off. We have some meters here for voltage, current, and power. We also have this button here for fault status. So when you click this, you start to receive information about the status of the various faults that can occur. If we want to go through them quickly, we have over temperature, DC leak under voltage, over current, over power, earth leakage, earth fuse, etc., etc. Several of these we'll see in fields that we can adjust their values and their status. If we go back to click on main and it brings us back to this main screen, we'll continue here on the lower left with information regarding the particular model that we're connected to. This is a FastPS 2020 400 watt bipolar supply. Here's its internal temperature, the earth leakage value, serial number ID, the date that it was calibrated, and its firmware level, and a picture of it. Now, one last thing to mention in this area is the number of sessions that are currently active, and it states 1 right now. However, if I were to open a new tab, it'll start showing that there is another session open, as you can see. So the number changes to 2. Therefore, it is possible to know if there's more than one user trying to operate the unit at once. Once any tab is closed out for that session, it of course brings us back to 1 in this case. Okay, we'll get to the unit controls in a little bit as we go further into that section, but for now, why don't we go to the menus here and start off with the console that we see here. Now, quite simply, there's no need for any other kind of program such as PuTTY or Terminal in order to access the unit via its command list. All of the commands are ASCII based, and so we can start typing them in right here to see the unit respond. Quite simply, if I ask for the version of the unit, which would be its firmware version, I type in VER, and it'll reply with the model as well as the firmware version that is installed. It says beta at the moment because we're just about ready to release this version to the public, so that will change. And it's that simple. So we have a list of commands in our remote control manual, and you can practice the commands from here, and then of course use those commands in a driver or in any other kind of setting if preferred, to do a low-level type of interaction with the supply. Moving along with the menus, we have epics, and this is better well known amongst the accelerator community. And so within here, we have submenus and subtabs. So pretty, let's say, self-explanatory. Boy, that took a while. Pretty self-explanatory here. We have the protocols. And I'll just do a scroll to give an idea of what's available. Database and records. As you see, they are specific to our supply, of course, and its parameters, including max and min values, heatsink temperature, DC link voltage, etc., ground current. Startup scripts. And then a console here as well. Now, I would like to mention that the IOC is built into the supply, running on the Linux OS that we have, the Yocto release. So that said, let's move on more into other features and other menus, such as the config menu here. And we're going to go through the submenus that are available. So under general, it is quite simply the ID of the unit. And this column here shows the fields that are editable based on the admin privileges that one has when logging in. So going to interlocks and limits, we'll break these all down, starting off with external interlock setup. And quite simply here, you would have a list of all the external interlocks available on the unit. So for this particular one, we have 2. For the FastPS1K5, for example, that would have a different number of them, since that model and that series comes with more. But with each one, you can have its name. You can decide whether it is enabled or not, as well as which level is considered active, the delay time that one would want before it trips, and that's that. Moving on to the limits, we start to see some fields that we'll also see later on in the internal memory section, but for now this is another way to access certain limit fields, including the maximum temperature of the unit before it faults on that, the minimum DC link voltage that you want to be allowable, as well as the earth leakage current, and overcurrent and overvoltage values. Of course, these would be higher than 0 during normal operation. Moving on further to the regulation fault limits. If you have the unit going 0.5 amps outside of its set point, or similarly for voltage, that's where you set that limit, as well as the time that should pass before it trips. Okay, pretty obvious. Now, this is a fully digital power supply, and that said, more than just being a switch mode, all the signals within the unit, including the feedback control, is fully digitized. That said, you can control and tune it via PID parameters. And so if we were to go into constant current, running the unit as a current mode supply, you would see the fields that are available for PID. Now, we're going to get into the architecture in just a bit, but these voltage values would be used more as the voltage limit when it's in current mode, and these are the values that would be used for the current feedback loop. Here as well, we can set output max and min values we would want. Now, these are for operation. These aren't for, let's say, fault tripping. So you would set whatever values you want here to stay within the operational range for both voltage and current. And if we close that and go to the constant voltage, you'll see the same exact thing if you're running the unit in voltage mode. However, let me back up for 1 second. I said I wanted to visit the architecture. So here it is graphically. Oops. Here it is in current mode. So you'll see the 2 loops within the main loop, and here is your main current loop, and then a voltage limit loop that operates as well. If we go to the loop for voltage mode, or I'm sorry, I should say the architecture for voltage mode, it is somewhat more simplified. That said, we have a few buttons here. Export is obviously to export the values. The oscilloscope expander is something that we'll get into a little bit later once we start showing the waveform generator and the built-in oscilloscope because it is possible to have them side by side running for the sake of helping tune a unit. And we'll show that in a bit, as I mentioned. But for now, let's continue here. We're going to go along more of these submenus here, going to internal memory. And this is where it shows all the fields that are available within the unit. As you can see, some are reserved and locked out based on the admin privileges. But going through them, a little bit more slowly, just to get an idea. Again, we have ones that are for ID and serial numbers, as well as MAC addresses, calibration date, calibration parameters, here's the calibration parameter set for the analog input. On the FastPS units, that can be available as an option with a plus or minus 0 to 10 volt range. For the FastPS 1K5, for example, it is standard. Here you can set your default slew rates for when operating the output, and we'll get to that in a little bit. We have a TFT front panel screen that can be timed out so that the screen goes black after a certain number of minutes. 0 would leave it on indefinitely. These are PID values that we saw previously, as well as the max and min output values. This is related to the state of the solid state relay. These values we saw earlier under interlocks and limits. Here you can change the name of the interlocks, as we saw that it was available here. If we go back to external interlock setup, you would see the name change here. And so on and so forth. That's the gist of it. If you have more than one unit in a system and you want to configure all of them, it is possible, of course, to drop in a configuration file here. And so one would not have to enter in the values manually. And then, of course, that said, you can export from a certain supply as well. And lastly, we have the network timing protocol. Again, this can be set up for larger systems that want to rely on timestamps and more of a robust synchronization method. Okay, let's move forward now. We have oscilloscope here, and yes, we have a built-in oscilloscope with our unit. We're going to get to this in a little bit later as well, once we start going into the output and the waveform generator, so we'll get back to that. Under admin, this is the same screen one would see once they first type in the IP address. Here's where you would put the password. Updates. Oops. Let's skip that. Over here, you would drop in a firmware file. And also, if the supply is connected to a computer that has an internet connection, we regularly ping our servers to see if there's a new version of firmware, so you would be notified if that's the case. Those files become available as a 7Z compressed file, and so you can download it, and then we would ask that you uncompress the file and then drop it into here, into the upload section. And then snapshots is here as well, where you have an option of which firmware version to work with and which build. Lastly, about us. A little information on that. Okay, let's get back to the gist of things, specifically the output of the unit. So going back to the unit controls here, quite simply, if I hit on, now the power supply output is turned on. At the moment, I do not have a load connected and I'm in voltage mode, so we're not going to see much current flowing outside of the unit. But we see it fidget back and forth here, and that's the response time of the unit. So moving forward, let's just do a simple example of going to the set point, and instead of using waveform for the moment, we have the option to use normal, which is considered the connection through Ethernet, the built-in waveform generator, or SFP. That said, we have all of our supplies shipping with SFP connectors except for the easy drivers. If we go to normal, this expands here as such, and we put in a value of, let's say, 15 volts. And why don't we slow this down a little bit so that we can see it ramp. We'll do 1 volt per second. Ramp is clicked, and if we hit apply, you will see on the voltmeter here that the output is indeed ramping up to 15. Simple. While that's happening, let's go back here for 1 second where we have the modes. Here you would simply choose between voltage and current mode. And we have the option of having the output grounded or floating. So they ship grounded by default. But if you want to go into floating, please reference the manual where it also tells you that you have to remove an earth fuse that we have in the rear of the unit. It's the fuse that would connect to earth ground. So that would need to be removed, and then you would set this into output floating mode. Okay. In the meantime, we're here at 15 volts. All of the meters are up and running. Everything seems okay. If we go to minus 15, why don't we speed this up a little bit, say 10 volts per second, apply, and we see that it's going on its way. Okay. Pretty simple, pretty basic, as it should be. If we bring it back down to 0, this time we don't do a ramp, we hit apply, it goes straight to 0. Moving along, we're going to get into the fun stuff now. So why don't we change the input to waveform, and let's hit edit. And here is our internal waveform generator. As you can see, there are many things to cover here, so let's start going through it. First of all, simply as I hover around, you can see that a more precise value is given of both the X and Y axes. Now you have options to turn that off, as well as to further manipulate the graphics with zooming, panning, zooming in, zooming out, auto scaling, resetting the axes, toggling spike lines, showing these hovers, comparing them, and of course downloading a snapshot of the graph as a PNG. So you'll find here many settings that you would expect from a waveform generator. First of all, let's start off with the waveform type. So you see here it says sine, and you would have the option of a sine, a square wave, triangular wave, or custom. And when you do custom, it gets more interesting because first of all, you can bring in your own file, and you have a field here to input, let's say, your critical points, if you would like to, on both the X and Y. And then based on that, you have an option for the interpolation. So right now it's set to linear, but you can change that to a step interpolation, polynomial interpolation, spleen interpolation, so on and so forth. That said, we can do the panning just by also grabbing the axes and holding down the mouse and then shifting around. Okay. I just wanted to do that to show better that you can get a better view of the graph. Okay. Auto scaling back. So you have that option to do a custom waveform. And here's where the values would be entered, again, for your critical points. This we'll get to in just a little bit with the trigger. So I'll get back to that. But we're back here with the sine wave, and simply you have various parameters that you can adjust for it, including its offset. Now we'll see that the axis did change, although it looks like the wave itself stayed, but we have it now starting at, let's see, 1.3, let's just say, but it was offset by 2. If we go back to 0, we'll see again, now we're back to 0 with where it was before. Of course, amplitude, put its maximum amplitude of the model, which is 20 volts. Now, the reason that it clipped here is because of our max and min thresholds. So we should change the max to 20, and then we'll see that it starts to correspond right away. Again, we have the min threshold set to -3, so it would clip in the negative. And considering the waveform was around this part at 0, we now see that it would be at -3. And so therefore, to fix that, we would put in our -20 here. And we now have our peak-to-peak sine wave at plus and minus 20. Frequency, we would adjust this as well. For the sake of us visually seeing it, why don't we slow this down a little bit and we'll make it at 0.5 hertz. That said, you see that the period adjusts accordingly. We have it set to 45 degrees, which is why it's starting here at 0 on the time scale. But if we change the phase to 0 degrees, we'll see it now looks more like a regular sine wave. Here you could run it for a certain number of periods. Leaving it at 0 would let it go infinitely. And the number of points that we have per waveform is shown here. So you can get quite some detail. Okay, that said, let's now go to the oscilloscope expander. But what I would like to do actually before that is go to the oscilloscope itself. So let's go back to main here for 1 second, go to oscilloscope, and one would find that we have a live oscilloscope, that monitors various values as the unit is on. So you can change those based on the channels. And you have the option to monitor 4 channels, let's just say. At this time, they're available as 4 different color codings, but more specifically as your voltage or current readback. That would be the instantaneous values, as well as your set point, voltage, and current. Now you can change the color of the channel. You can have the waveform filled. You can set its offset as well as its scale, which would be similar to the scale on the probes. And that's all available. If we go back to basic, you'll get functions and features that you would expect from a standard oscilloscope. So that includes the triggering mode, as well as, I was going to jump straight to trigger. Let me do that now. So yeah, since we show the triggering modes, let's go straight to trigger here, which would have it enabled or disabled. And you would choose which channel you want to trigger off of. Now again, these are the channels based on what you chose in channels. And they would either be the readback of the voltage or current or the set point values of the voltage and current. You can decide to trigger on positive, negative, or both edges, as well as the value on the X and Y. Pretty self-explanatory. Up here you have a legend that shows the color for each channel, and you can toggle that on and off simply by the legend. And going back in reverse here, you would have the sampling window on the horizontal scale. So right now it's set to 2. Therefore, if we scroll over, you see it is up to 2 seconds. That can be changed. Put 5 seconds. And one would find that it expands out to 5 seconds. Okay. All that said, let's now put some things to work. So why don't we go back to the waveform generator? We'll now click on the oscilloscope expander so we can see them both at the same time. Let's put this back to 0 degrees. Let's set the amplitude to 10 volts. We'll put the min and max thresholds to their maximum. We said we'll slow it down a little bit so that it's easier visually to notice what's going on. And let's see what happens. We have it set to sine. Let's apply it. And turn it on. Now this here came up simply because the unit was already on before. As it's showed here on, and I hit on again. But it's good to see also that you'll have an error message pop up like that. So that's very good. Okay, we're operating, as we can see, we're doing the sine wave at 0.5 hertz. And accordingly, we're getting the feedback here visually on the oscilloscope. This is the voltage. The current is just about 0 because, again, we have no load connected, and set point current doesn't even matter. So just to show you as an example, we can change some parameters here. Keep that filled if you like that better. We can disable the set point current because we're not needing that. And so here's our graph now. If we were to change the waveform to triangular, hit apply. We would see that it's now in a triangular waveform shape. Of course, this is not going bipolar. This is only staying in the positive polarity, as we can see. So that's what we get. Don't forget that every time you change something, if the unit is still on, you have to hit apply. So we're going back to waveform generator now. Now, it's not common to change waveforms while the output is still on. Of course, that's not to say that you can't have a custom waveform that would do that, but just from the GUI, one would not consider such an operation under serious test and measurement. But just for demonstration purposes, that's what we got. And things are working just fine as expected. Lastly, one big feature of this, and the reason why we have the ability to show the waveform and the oscilloscope side by side, is for PID tuning. And so, for example, going back to waveform, let's stop this for 1 second. And we'll turn the output off. But if we were to do a square wave, and here's a representation of how we turned it off. If we were to do a square wave, this is what would be used for tuning. So let me put that in, hit apply. Excuse me, sorry, I have to hit wave start first. So the output needs to be on. Once again, that was a good example of showing where the error messages pop up and they give you a warning. So we have the output on first, then we hit apply. Perfect. So as we can see, the unit is going to 10 volts quickly in a square wave fashion. And this is what one would be able to use to tune the unit with a load connected. And now it would allow us to enter in the values and to apply them. And while the square wave continues, we would see changes in the output corresponding to the reactance of the load. And so this is a great way to tune the unit. That said, pretty soon we'll take it even further with an auto-tuning feature that will be built in, and none of this will be necessary, although it will be available for fine-tuning if one would like to do so. But the auto-tuning will allow someone to connect the unit to their load and the unit will tune itself. Okay, let's stop all that. And I would say that's about it for our first video here. I think we covered the basics of what's available. And we would like to thank you all for joining us in this first one. As I mentioned, we will have other videos coming out shortly where we'll go more in depth of certain features such as tuning, use of the waveform generator and oscilloscope, etc., etc. So stay tuned for those. Until then, thanks once more. Have a good day.